Hello, I'm Stefan Greber. I'm the project leader for LXD, and today I'd like to go over some work that we've been doing recently around simplifying the deployment of LXD clusters, both in the cloud and on physical hardware. This is using Juju, which is another project that's developed by a team at Canonical. And what Juju does is make it quite easy to deploy the exact same set of software on a variety of different platforms. So today it's going to be against the public cloud, but can be against just about any of the other clouds, or on bare metal, or against the Kubernetes cluster as well these days. So first thing first here is going to be installing Juju itself. So snap install Juju. And once Juju is installed, the first step is going to be to get a Juju controller and model up and running. So for that, I'm using my local Google Cloud effectively. So there's a Montreal region. So I'm going to be bootstrapping a controller onto that. So the name of the cloud is Google. And the name of the region is North America, Northeast 1. And let's call that Google Compute Montreal. So what that's going to be doing is Juju will first look for credentials to talk to that cloud on my local system. It found them, at which point it can talk to the Google Cloud API to, in this case, create an instance on there. The instance then fed some amount of metadata that causes the Juju controller itself to download and install in that instance. Once that's all done, then my local system will try to reach to that VM until that's all ready, and then complete the installation and give me an empty Juju model to work with. So at this stage, if we go look into the cloud dashboard, we should see a VM was created. Refreshing the list of instances. There we go. So you can see a Juju, an instance named Juju in a random identifier. It's running in North America, Northeast 1 Zone A. It's got a internal external IP address. And if we can go look at what it is as far as resources. So it's got 4 vCPUs and 3.6 gigs of RAM. So they just got created. On the storage front, it's using 10 gigs of disk, persistent local disk, and it's using Ubuntu 20.04 as its base operating system here. Now, let's look at how far it got as far as deploying the controller. So it managed to connect to that instance in Google, and is now running the script to actually set up the controller on there. That shouldn't take too much longer, at which point we can get Juju to actually deploy LXD for us. So there we go. Bootstrap agent's now started. It's contacting the Juju controller to make sure that it can be contacted directly through Juju's own protocol instead of through SSH as it was doing earlier. And that usually takes a few more seconds, and then I'm gonna get into a working model. There we go. So looking at the list of Juju controllers, I can see one controller in GCP called GCP Montreal. Because I don't use the cloud very much, my account is completely empty, so I didn't mind giving full admin credentials to Juju. If you're using the cloud for production services, you can create different projects and do a bunch of tweaks for the exact permissions that you give it. Now on the model side, you can see 2 models were created. One that runs the actual controller instance that we're seeing. So you can see one machine, 4 cores used, and then the default model, which is the one we're going to be using, and it's completely empty at this point. So before deploying anything in there, I'm going to need to do a tiny bit of a tweak, which is Juju set model constraints, like so, and core is equals 4. Oops. Missed an S, there we go. That just means that every single instance deployed within that model should have at least 4 cores. That's pretty much the minimum if we want LXD to work properly. Giving it less than that, you end up with cloud instances that are terribly slow and take forever to deploy. So I'm going to be deploying LXD. I want 8 instances, so 8 instances of LXD. We're going to want them clustered together. So the config mode equals cluster. And I also want them to use some persistent storage that's dedicated for LXD. So gonna be getting some extra storage from Google Compute, 50 gigs a pop, and just 1 disk per instance. Running that, we'll instruct the controller to start deploying that solution. There we go. And then you can run Juju status. Every 5 seconds, it's going to be updating the view to see what's going on. So right now, it just shows it's waiting for machines to deploy any software on. And the bottom part, which shows the machines, is going to start updating as machines are getting deployed. So you can see the first one got created. It's got an IP address assigned to it. And then the rest are going to be filling in pretty quickly. Can switch back to the web view, just see what's going on there. Whoops, clicked the wrong thing. Let's go back. Come on, there we go. So I can see that a few of those already got created, usually within a few seconds later, then to get all of them. There we go. And if we go look at one of them, the CPU is the same as the controller, so it's still 4 vCPUs, 3.6 gigs of RAM, because that matches the requirement for this model to have at least 4 CPU cores. If you didn't set the constraint on the model, the default, I believe, is 1 vCPU core, so then you end up with something really tiny. So the controller takes a larger instance type than the default, effectively. Here we can see 10 gigs of disk. I'm surprised that the additional disk is not attached yet. Is it maybe just because I caught an instance slightly early on? Let's pick another one. Let's pick instance 0. Oh yeah, there we go. So that one is fully configured and does have the 50 gigs of additional storage attached to it. All right, so that looks good. Now let's go back to the terminal and see where we're at. So now all the instances have been created. The first one is now running, and it's currently installing the LXD snap package. So it's installing our latest stable release, in this case 4.19. Okay, it's done. And so that first one, there's an asterisk next to its name here. That means it's the leader as far as the Juju deployment. So in the case of building a LXD cluster, it means that this first instance is going to be bootstrapping the cluster. And then the others are just going to be joining the cluster. So that's all handled automatically by the charm. So now we can see the other instances are joining the cluster as soon as they finish installing LXD. And I guess in a few seconds, the cluster is going to be all assembled. You can kind of see them going one by one by one and all joining. Okay, almost done. And one of them is still installing something. Okay, 2 of them are still yet to join. Okay, last one is joining. All right, everything is green, everything's active, running, all good. So with that, we should have a working LXD cluster. So the first thing to do to look at how that was all set up is we can do Juju SSH and then the name of one of the machines, well, one of the deployed LXD units in this case. And that's gonna get us a shell inside that particular instance, then go to root and look at the cluster. And here we can see a 8 nodes cluster. 3 of them are database voting members, so those are the ones with roles set to database. And then we've got 2 standbys, that's the normal LXD config, and the rest are just acting as normal normal cluster members. So it's all looking good. There's nothing running on it. The storage is configured to use ZFS on the, so the pool is called local because it's not Ceph effectively. And if we go look at a specific machine, so say ours, then we can see it's using the external drive that was attached to the instance. So it's coming from, you can say by ID, Google North America, Northeast 1C, and then the drive. So that looks all good. On the network side, out of the box, what we do for clusters is we use a fan bridge. So that's why there's a LXD fan bridge set up in there. And that means all the instances running on top of that cluster will be able to talk to each other. That's not necessarily the setup that everyone would want, but that's perfectly fine. It deploys a working cluster of working API. Once that's done, you can reconfigure everything to your heart's content. So let's go back to my machine. And so the cluster is working, but it's not super useful because it only works right now if you connect specifically to one of the machines through Juju SSH or something like that and then deploy things. It would be nicer if we could connect to it from the outside. So for that, we're going to be changing one tiny bit of config, which is the setting LXD listen HTTPS to true. So that effectively instructs Juju to reconfigure all of them to now start listening. So if we look at the old config only has the cluster endpoint configured. So nothing external can connect to that. Now if I change the Juju config, after a few seconds, all of them are going to have the core HTTPS address now set properly, which allows regular clients to connect. So that's a good. And then there are Juju actions. So I believe we can do actions, LXD. Yeah, so there are 3 actions that the charm exposes right now. Add trusted client, debug action to get some debug information, and show pending config, which is also meant for debug to see if an instance shows as needs reboot, you can go see why it does need reboot. In this case, the action I'm interested in is the add trusted client, because that lets us add the certificate of a trusted LXD client into the cluster, and then we can connect with that. So I'm going to be using LXD0 as the target instance here, run the action add trusted client. The name of the client I'll set to Dakara because it's the name of my machine. And then the cert is the actual client certificate. It needs to be between double quotes. So snap LXD common config client cert. So that's my own client certificate from my machine. And I run that, and a few seconds later, that effectively ends up getting added to the LXD trust store. Can go check that if we want by going to trust list. So we see all the different clustered certificates here at the bottom, but then the top one shows a client certificate called Dakara that was added just now. So they're disconnecting again from that machine. Now, from my laptop, I can do LXD remote add cluster, and then the IP address of one of the instances, doesn't matter which. So if I go back to the Juju output from earlier, I can just get, say, the IP address of, let's do instance 6. And it's added. Like, it doesn't prompt for the password or anything because the certificate is already trusted. So you're effectively done. Then it's possible to switch over to using that cluster with remote switch. And now if I run LXD list, I'm listing the instances running on the cluster. Let's spawn a few instances. So let's do 1.2.20.04, call it C1. So now the cloud instances are, well, one of the instances has been picked to run that LXD instance. It downloads the image, unpacks, spawns the container. Let's do just a couple more. And as I showed in the past in other LXD cluster demos, those are just going to be automatically balanced across the cluster. So do 2 more Ubuntu. So the first one effectively downloaded the image from our image server, and then the other 2 just downloaded the image internally between cluster members. So between those instances in Google Compute. I can do Alpine. And what can we do? CentOS 8. Running out of short names, just call it CentOS 8. That one takes a tiny bit longer to unpack usually. It's a bit larger. Okay. How many do we have? 3, 4, 5, 6. It would be nice to have 9. So let's just do a few more. Let's do Arch Linux. Then maybe open WRT and Debian or something. Okay, so that's Arch running. Then open WRT. That should be a pretty small one. Oh, that's a good question. I don't know what the releases are of OpenWRT. Oh well, let's do Debian SID. Okay, I guess we can do an older Ubuntu. Actually, an older, still supported Ubuntu would be better. So that should be 3, 6, 7, 8, 9 instances. So that does what I want, which is to just show that it should be now spread across all 8 servers. So we can see instances on 0, 1, 2, 3, 4, 5, 6, and 7 in there. And that 0, 0, the instance 0 has 2 because it just went around at the end. Also, you can notice that like all of them have IPv4 only. That's coming from the fan bridge. And the magic that the fan bridge does is that it makes it possible for all of those to communicate quite nicely across multiple machines. So in this case, I mean the instance called Debian, so this one. And let's say that's on instance 7. And if I wanted to ping C1, that works just fine. So there's no need to like manually configure some network overlay or anything. It just works out of the box. That's quite nice and convenient. So that's pretty much all there is to it at this point. The LXD charm really makes it easy to deploy either standalone or clustered LXD deployments on any platform that Juju supports. So if we go look at the charm webpage itself on the charm hub, there are some instructions here on how things work, including kind of what I showed today with some of the config around getting the LXD version, having it listen on the network, how you can even sideload specific snaps if you want, how the storage works, so the same kind of config I showed here, known issues, and at the top you can also go look at configuration. So that's all of the configuration keys that are currently supported. It's possible to configure just about any of the snap config options through that. It's also possible to apply our standard kernel and sysctl hardening. So that's what's normally defined as LXD production setup if you're looking at our documentation. So those can be done directly through Juju by setting the kernel hardening or the sysctl true or false. It actually defaults to true for both of them. So if you've got some issue with that and you want the hardening to be disabled, it's possible to do it that way. Juju also has a concept of interfaces and relations that can be used to connect multiple applications together. And the LXD charm exposes some of those. So it's possible for someone to write an application that then interacts with the LXD charm to get their certificate added to either a standalone LXD or a LXD cluster so that they can actually interact with it. And all the user would need to do is do Juju relate and then the two charms. We're also looking at integrating some of the newer features of LXD through that so that it's possible to, for example, relate LXD with a BGP deployment directly, and it will configure LXD accordingly. And same thing with the recently added metrics. We're looking at, over the next few months, adding logic so you can relate the LXD charm with the Prometheus charm, and it will automatically configure scraping and all of that. So it's pretty convenient. It's especially useful because you can run it easily against Google, Amazon, Microsoft Azure, Oracle Cloud, or local MAAS, or whatever you want, and get effectively the same behavior with the same config options and the same everything. So I hope that was useful. If you want to try and deploy a quick LXD cluster for yourself, maybe give a shot to Juju and the LXD charm. And if you've got any question around Juju, the charm, LXD clustering, or anything, leave them down below in the comment section or on our community forum. And I'll see you in the next one. Thanks. Bye.